Hello and welcome everyone to a new episode of Your Friendly Physicist and Other Nerds. My name is Lucas, I'm the host of this podcast, and usually I talk with other scientists about their research and science stories. But recently I stumbled across a super nice story which I really want to tell you. So get comfy with your favorite beverage, today it's story time. Currently I am working at a nuclear research reactor in Munich. And when I heard first about the story that I'm going to tell you in a minute, I was super excited because it's the story about a nuclear reactor. But this reactor was not built by humans, it was built by nature itself. And this was 2 billion years ago. And only in 1972 we found out that this reactor actually existed. In May 1972, workers at a French reprocessing plant noticed something very suspicious about the uranium they were getting from a mine in Gabon, which is in West Africa. Because this uranium had an unusually low concentration of the isotope uranium-235. This isotope is the fissile material which is crucial for nuclear reactions. And typically the isotopic ratio of uranium-235 is consistent worldwide. So here, that the concentration was lower was quite puzzling. So scientists investigated the source. The source was the Oklo mine in West Africa. And there they found yellowish uranium all over the place. And they took samples, conducted tests, and made an astounding discovery. They found fission products, elements and isotopes that only form from nuclear reactions. And this was proof that a natural reactor had existed there around 2 billion years ago and long before Enrico Fermi achieved the first human-induced nuclear fission in 1942. And now, of course, the question arises, why exactly there in Oklo? What is so special about this mine there that there a natural reactor formed and actually worked? And to understand this, we need to dig into a bit of the basics of nuclear fission. So uranium-235, this naturally occurring isotope. This isotope undergoes fission when it captures a neutron. This means it splits into lighter elements, further neutrons, and also releases energy. And for an ongoing nuclear chain reaction, we need a specific concentration of uranium-235, which is around 3%. And this was exactly the case in the Oklo mine 2 billion years ago, because there we had regular floodings, and these floodings washed the uranium into underground pools, and there it accumulated until it reached a critical mass. So we had enough of this uranium-235, which is basically our fuel element, to start a natural nuclear reaction. But beside our fuel element, we also need a moderator, because the neutrons that are emitted are too fast to continue this chain reaction and to split further uranium atoms. So we need a moderator to slow these neutrons down. In Oklo's case, we had water around the uranium, and this water acted as moderator because water is a pretty nice solvent to slow down neutrons. So this unique combination of an enriched uranium fuel, so to say, and the moderator, the water that was present around, was just the perfect environment for a natural reactor to be created there. And moreover, this reactor was preserved for billions of years because the water moderator also worked as a pretty cool natural safety mechanism. Because when the reactor heated up, in the chain reaction you also release energy, the water would eventually boil away and thereby stopping the chain reaction. Because now the emitted neutrons were again too fast to continue to split uranium atoms. So the chain reaction stops, the area cooled down, and water eventually would return. And this would restart the reaction because now we have the moderator back. And this cycle of operation and cooling, this cycle likely continued for hundreds of thousands of years. And this is actually a pretty cool part, because the study of these fission products and also how they were distributed showed that these materials didn't migrate far from their origin. And this is actually a pretty big deal for nuclear waste management, because it means that under the right conditions we could potentially store nuclear waste safely for very, very long periods. And of course, in addition, it validates a lot of theoretical models about nuclear fission and isotope behavior, because we now can study these processes over geological timescales, basically in a natural laboratory. And this is super exciting, I think. And of course, this discovery also challenges the idea that humans were the first to create sustained nuclear reactions. So nature beat us by billions of years, literally. And even today, there is still ongoing research that focuses, of course, on nuclear research, like waste management or the exact mechanisms of these natural reactors and isotope behavior, etc., but also about the early history of our planet. I mean, it's quite interesting to know that 2 billion years ago there was liquid water around, and that Earth's crust contained a significant amount of uranium, which is important to know what was going on 2 billion years ago. And even more exciting, the discovery of these Oklo reactors sparked the imagination about finding similar natural reactors elsewhere on Earth, and maybe even on other planets. I mean, imagine this. If we understand how these reactors formed and operated, we could uncover new ways to harness nuclear energy, or even find signs of ancient life-supporting conditions on other planets. This was the story of the natural nuclear reactor of Oklo. A fascinating story, right? It took us back billions of years, and we found out incredible insights into nuclear physics, geology, and our planet's history. I think it's a beautiful reminder that nature is full of surprises and, really has been conducting its own experiments long before we came along. So thank you for joining me on this short journey through time. I really hope you found it as intriguing as I did. If you enjoyed this episode, you could subscribe to this podcast or leave a comment in the comment section. Until the next time, stay curious and keep exploring the wonders of our amazing world.